This webinar is on operational technology, specifically looking at how can we take all this work we've been doing in IT security for the past 20 years and begin to expand it beyond that traditional desktop, right? Begin to expand it beyond even the mobile devices and some of the newer devices, but look at that operational technology that's really present in every one of our buildings and every one of our organizations in one way, shape, form, or another. So with that, my name is Wolfgang Goerlich. Just a couple things about me. I'm the Director of Security Strategy over here at CBI. 20 years in IT, started off in medical, then I worked in financial services for quite a while. Past 10 years of it being IT security focused. So my role at CBI is to get engaged with strategic accounts, to get engaged with strategic projects, and through that role, through the past maybe about a year now, I've been pretty deeply involved with these ICS projects, right? Looking at industrial controls, looking at SCADA, looking at ways that we can assess those, figure out what the security posture is, and help organizations raise those. So the agenda today is pretty straightforward. I want to propose that there's really today two layers of security. There's traditional, the desktop, the mobile, the server infrastructure, and there's the operational, those industrial controls, the environmental controls, the things that are driving our manufacturing, the things that are getting food to our table, the things that are in our everyday life governing the physical environment. I'm going to talk briefly about what the threat landscape looks like and what some of the threats to that operational environment is. Both in terms of high-profile threats, but also in terms of more likely threats. What are people seeing on the ground? What are we experiencing from CBI's perspective when we get called in to help triage environments? And then we'll look a little bit about the compliance ramifications, both checking the box and going beyond checking the box, and how that will grow and morph as we move from the industrial control systems into the Internet of Things. And then we'll talk about how to assess and gain some visibility into the operational technologies that are in your plant floor that you're responsible for. And with that, I always like to start off with why, right? Why are we here? Why are we even looking at this? And it's pretty fundamental. As security teams, as security managers, as security officers, we're called upon to protect our organization and our organization's ability to achieve its mission. And for quite a long time, that has meant traditional IT, right? Can we protect the servers? Can we protect the networks? Can we protect who gets in and gets out? Can we set up good access controls and identity and access management? Can we know when something's going off the rails, as well as recover, right? Putting in place those incident response procedures to get things back operational. And we've made some really good strides, I think, as an industry over the past several years to come to grips with these problems. I mean, sure, we're still in many ways behind the curve, but at least we got some good visibility into where the risks are and have some good roadmaps that have been developed to address those risks. Everything from infrastructure to operating system to the applications that we develop, etc. But as we begin to do that, we begin to expand that, more and more I hear security leaders are being asked, yeah, that makes sense, but what about our heating and cooling? What about our elevators? What about the manufacturing plant? Yeah, that's fantastic that we've got good understanding, good grasp around our corporate network. But as a biomedical manufacturer, what visibility do we have into our biomedical devices? Things like that, right? So as we begin to get into that, the why is pretty simple. As we protect organizations, we have to protect more than just that traditional IT. We have to really begin to think of it as two layers and tackle the operational side. So when we talk about two layers, what are those two layers? Well, obviously, we've got traditional information technology, right? Your server rooms, your raised floors that we've all known and come and cut our teeth in. And I'm sure everyone on this line has a good story about one cold night, stuck underneath a raised floor running cable just so we can make sure we get the infrastructure up in time. But what is this operational technology? What's this side of it? Well, part of it is that cold floor, right? It's the HVAC system. Part of it is the fire extinguisher system, right? The controls that govern the wet pipe and the dry pipe. Part of it is the technology that allows us in and out of the building itself. Those swipe cards that deactivate the locks and the man traps. If you expand beyond and look at operational technology, this is the definition Gartner uses, and they say it's any hardware and software that detects or causes a change through the direct monitoring or control of physical devices, right? The processes and events in the enterprise. And traditionally, when we're looking at this, we think of it in terms of like the corporate network, where you've got your ERP system, your production systems, your email systems, everything that we've been looking at. And then you got those operational side. Now for power plants, for heavy ICS users, and that is a majority of the environment, right? Your SCADA network, which has got your older systems that are running software talking to your production network, which is actually the R2Us, the PLCs, the devices that are going ahead and enacting change, right, are enacting the process or are collecting data and getting it back to the SCADA system, back to the corporate network. But of course, not only does this play out in a power plant, it could easily play out in a food producing network where you've got your corporate systems and you've got SCADA that's governing the processing of the livestock, the wrapping of the livestock, right, putting on the packaging, cooking it, putting it into the trucks, etc. It's also biomedical, right? So instead of it being corporate network, you've got your networks that the doctors are going ahead and working on. But of course, you also have the individual devices, the insulin pumps, the heart monitors, what have you. They're all on separate networks connecting back. But even without being in that area, we still think about things that organizations that traditionally haven't looked at ICS, right? So it could be something like a university that has to worry about their elevators, or it could be something like a county government who's got water pumps and different systems like that. Every one of our organizations has this ICS at some level. It's just a matter of how deep do they have it and how integrated is it back into the traditional IT security realm. And there's some very real challenges, right? So ICS equipment is very expensive. There's a great deal of difference between the people who are maintaining those operational controls and the people who are maintaining the traditional controls. And just like a simple compare and contrast, right? A typical IT asset, maybe 1K, maybe 10K. On the industrial side, right, it's an entire order of magnitude up. It's like $10,000 to $1 million, right? These are not systems that we can just have a test lab to go ahead and try out different things, or have multiple redundant systems in case something tips over because of the cost, because of the investment. And because of this cost and investment, we tend to maintain them for a lot longer. Typical corporate IT, 2-3 years, maybe a 5-year refresh cycle. On operational technologies, we're looking at anywhere from 20 to 30 years. These are devices that are expensive, are put in, and are maintained for a very long time. And that brings up its own security challenges. It brings up things like, hey, what do we do when we have to maintain Windows XP beyond end of life? What do we do when we've got DOS systems or Windows NT systems still out there? How do we maintain these systems when the software vendor is no longer providing patches, right? Because it is not easy to patch these things. It's not easy to scan these things in many cases. A lot of the typical scans that are run, for example, in a vulnerability assessment program, you wouldn't want to turn on your OT, because if you go ahead and run an intrusive scan, which Windows and Linux has been pretty much purposely built for them and scanned over the past 5-10 years, you're in a situation where suddenly you're getting a very, very unhappy guy calling you because the production line's down or the elevator's not working or, God forbid, the sprinkler system went off, hypothetically speaking. So we can't necessarily scan these things. We can't necessarily patch these things, as well as they are governed by different teams, right? So oftentimes the operational technology rolls up to director of operations or chief operations officer. In things like county government or universities, it's being maintained by your facilities folks. So we've got different teams with different focuses, smart people, much like we see in the application space, right? Smart people doing the job, doing a good thing, but focused on something quite different than what we would focus on in the security space. And of course, again, it's more than just power generation and heavy industrial manufacturing. We're talking about food processing, biomedical, and facilities, everything up to the elevators. And I had a great conversation with this one guy, and he's like, "Yeah, we just had a denial of service, and that's okay, that's interesting. Yeah, but it was a very unique denial of service." I'm like, "Well, okay, I've seen unique denial of services." "Yeah, but you don't understand. This denial of service came from our elevator network." I'm like, "Wait, back up, your elevator network?" Their elevator network had been compromised. And I doubt that attackers knew that it was an elevator, of course, but it had been compromised and was being used to go ahead and scan out. So these are the type of very weird situations you run into, because heretofore the elevator was not under the directions of IT, it was not under the direction of CISO, it was a facilities problem until it became a security problem. So when we talk about maturity, we talk about getting ahead of these things. We oftentimes think about it like, get cape, wear cape, fly, right? We want to start somewhere, mature the process, and get it to a very high level where you can be the hero and you can prevent the outages. And in many cases today, IT security is to the wear cape, depending on where you're at. Some areas may be flying, and some areas may be just coming on board. But overall, IT security, we've been working on it for 10, 20 years. We're getting somewhere. On the other hand, operational security, we're like, cape? We need a cape? I didn't think I needed a cape. All I knew was I needed to control my elevators from home when I've got work to do. So we clearly have a long way to go to gain visibility and to educate the folks who are responsible for this technology to begin to put those controls in place. And at the same time, of course, we're facing some very real threats. Some of them are very well known, very publicized, right? So there was the Bowman Avenue Dam that was recently in the news because attackers got in and they were able to get to the controls for the dam, and it, of course, was a very public event. Also, of course, the Ukrainian power plant, which they had an outage, to put it put a little bit of an understatement on it, and it was traced back to attackers who were able to break in and get to those SCADA systems. But even when you look at something like, hey, the U.S. government said, right, in 2007 that hackers could take down a power plant by physically destroying a generator with 21 lines of code. I mean, that's a lot of hype. It's a lot of, oh no, they're going to come in and they're going to flood our dam and they're going to blow up our power plant and whatnot. What is the reality? Sure, those things exist, so those things are real concerns, but I think for a lot of people on the phone, it's beyond that hype to more realistic concerns, right? So more realistic concerns could be a denial of service targeted at an ICS device, or an ICS device becoming a target of opportunity. We're going to scan out the network because we're criminals. We're going to look for unpatched systems because that's what criminals do. We're going to identify that Windows XP is everywhere. We're going to compromise that Windows XP, not knowing, most likely, from a criminal perspective, that they've now gotten into facilities controls or gotten into sensitive areas or whatnot. That's one that we're seeing quite frequently because everything is scanning everything. That's the nature of the criminal element today, right? It's all about those targets of opportunities, and they're not necessarily at this point in time differentiating between a Windows XP box that's used for home versus a Windows XP box that's driving your industrial controls. Likewise, too, we're seeing once those targets have been compromised, they're being used as pivot points. So now that we're within this environment, we can then get on to the next point. Target is oftentimes brought up with this because, of course, the bad guys went in through the HVAC system. But Target was just the biggest breach, right, of that time period. Scores and scores of organizations will tell you over beers the very same thing. We had some systems, our vendor was supporting our HVAC or whatever it may be, and we had opened it up to remote access, and someone compromised that remote access and used that to pivot into our networks. So you got targets of opportunities, you got denial of services being aimed at the systems or coming from the systems once compromised. You've got ransomware that's going to take root as well with these older systems as the ransomware gets into the environment and then spreads everywhere out, causing outages. You got the ability to pivot. And of course, you got concerns where you've got real world business outages or medical outages when you've got this older equipment that when scanned with simple scans will tip over, right? So if you can, within the comfort of your own data center, fire off a simple network scan and knock over an insulin pump, that's pretty scary, knowing that if a criminal gets in, the first thing they're going to do is scan out your network. So these are some of the very real threats that we see on a day-to-day basis, attacking this operational technology above and beyond some of the hype that you're going to see in the news. And the main concern is what? Well, if I'm being asked as a CISO to build a roadmap for this, how can I do that if I don't have good visibility, right? How can I create a good roadmap if I don't have a good network diagram, a good asset diagram, good flow diagram, good understanding of what the technology is? And that's where I think a lot of people are still at the point where they go, what's a cape? Once you get past the what's a cape phase, it's all right, where do I need to go to get started down this road? Compliance provides some basic frameworks, they always do, but a lot of the compliance is still focused primarily around the energy sector. So with this industrial controls, you can find great information if you're running a power plant in terms of how to segment them, how to secure them, how to lock them down, what the right controls are. However, with ICS equipment being in facilities or in manufacturing, we don't necessarily have the benefit of those same controls. So there is a gap there, right? We can't necessarily say, okay, we're going to comply with this industry reg and then use that to build our roadmap. Furthermore, we really need to get that good inventory. Step one of any one of these processes is to get a very solid asset inventory and network diagram. And it's one of the things actually that is usually seen as being a very positive outcome from one of these assessments, right? So why would we let you in and look at this? The owner of the operational technology guy might say, I don't want to be down, he might say. I don't want my business to be interrupted, right? The COO or director might say, I've got to have a certain uptime, I've got to have a certain level of reliability, and this is a problem. And then, as so oftentimes in security, we're in the process of selling it to them and explaining why we're doing what we're doing. And one of the main things that could be a selling point in doing this thing is, hey, you've got technology that's been around for 10 to 20 years. You've got technology that is in every nook and corner. You're responsible for all these technologies. As part of this process, we will develop a good asset inventory and a good tie back to what these things are. And 9 times out of 10, when we're having these conversations with the people who own the technologies, with the people who have operational oversight and controls, that's a benefit to them, and that's key to building a process that's delivering value to them as well as satisfying the security requirements. So we need to unify our asset inventory. Of course, we also need to unify our risk framework and our controls framework because so oftentimes there isn't one in place. There's usually a pretty good risk framework on the IT side at this point in time, but not necessarily on the operational side. One of the main starting points for that, of course, is NIST, being the standards-based organization that it is, as well as now providing the cybersecurity framework. They've got the security controls for IT very well documented in 53B. With 882, they delve into the industrial controls, specifically with respect to installation into safety and the physical concerns, but also with respect to here are some requirements and some ways to wire that ICS device into the network, get it on the wire, and yet make sure that the availability and integrity of that device and of the equipment it's connected to is controllable, is sustainable, and is monitored. So in building up the framework and whatnot, we can align back to NIST, and that provides a high-level overview of what controls we need to put in place and what standards we're satisfying. Then once we get that in place, we can then begin integrating in with our risk treatment programs, integrating in with our overall risk ratings, so that we're no longer just looking at traditional IT, but we're also considering these risks that are introduced by these operational technologies. So how do we do that? How do we put together such a framework? What does it look like? Well, it starts, of course, with incredibly careful planning because availability is key, especially in manufacturing, in medical, and government. Availability is key. We cannot go into these environments and just start pulling things out and looking at them. So we got to start off with very carefully planning out the approach. And a big part of that is communicating and opening up those levels of dialogue between the people who are responsible for operational technology and the people who are responsible for IT. I said a little bit ago, it reminds me a lot of the challenges we face in the application space. If you tuned in for the webinar that I gave for securing software development, it's much the same thing. You've got a different culture, right? In that area, it's your development team. You got different priorities. In that area, it's production. You got a different way of communicating risk and a different way of evaluating things, and not necessarily the same vocabulary for talking about these concerns. So likewise with software development, where you bring those teams together and you build working groups and you make sure that you're delivering additional value, such as speeding to delivery and whatnot, you want to do the exact same thing with your operational folks. How can you go through and, as part of the security process, help them achieve their goals better? How can you communicate in a way that makes sense to them? How can you give them something of benefit, such as asset inventories and what have you? And building those coalitions such that when we're going through the security process, we're also working lockstep with those operational folks and using the assessment process as a starting point for educating them on, right, building security awareness and communicating what it means to secure these technologies. So that's planning, that's building coalitions. In terms of the actual technology assessment, a lot of it has to do with looking at this network diagram. There are junction points where the network traffic, right, transits from the operational technology to the traditional IT. Those are the areas that we want to tap into. One of the best ways we've found to conduct these assessments is to do network captures, right, to capture the packets as they're communicating back and forth between the production SCADA and corporate networks, and then run them through passive vulnerability scanners, such as the ones made by Nessus. So that allows you to identify the types of equipment that are communicating on the line. That allows you to, once that identification has been made, to query those databases, the vulnerability databases, to say, hey, what are the known weaknesses of this technology? And to begin to put together some insight into what goes where and how it's all wired up. Now, of course, there's a whole bunch of nuances to this that I'm not going to go into the webinar, such as if you're in manufacturing, what's your manufacturing cycles? Are we capturing and doing the right time? If you're in medical, what type of shift change and floors and equipment that's used for treatment right now is being applied? All those types of things have to come out during the planning phase, so that we make sure that when we do this, we're doing a statistical sampling, but it's a relative sampling that gets enough data to give us a good enough insight as to what's absolutely operating. So that's packet captures. You're also looking at the configuration files, right? So we can pull the configuration files out of the SCADA environment. We can pull the configuration files out of the PLCs, and we can run those same configuration files through vulnerability assessment tools. We can look at things such as those from Digital Bond, and that gives us an idea of what controls exist in those technologies and what controls are missing in those technologies. So that's a good way to begin building the asset inventory, begin building insight into the technical state of those environments, and then it's just kicking it old school, right? Yeah, I kind of laugh because in a way this is very much the way we started off doing assessments. We didn't start off doing assessments sitting at our desk running scans. We would walk over into the data center and look at the equipment, right? Vulnerability assessment by shoe leather. And likewise, we didn't necessarily always have vulnerability databases. We would pull the manuals and read the manuals. And it's that same combination, getting the manuals down, checking through, looking for the known vulnerabilities and the recommendations, the release notes, as well as doing a physical walkthrough and identifying the technology we found and where it's in use and what it's doing. Those same techniques come up again and again and are applicable to this process. So once we have an idea of what environments we're going to tap into, what segments we're going to listen to, what config files we're going to read, with an idea of recognizing that we're only going to be getting insight into a certain percentage, hopefully a majority, but a certain percentage of the operational technology, we can then begin to put together our plan and figure out how we're going to execute on that project plan. But before we do, the key thing at this point is to simplify that plan, right? Maybe we thought we would read X number of manuals and walk Y number of plants and scan Z number of segments. But once we put all that together, we recognize that there's a finite amount of resources, there's a finite amount of time, and there is a real world impact to everything we do, not only for our security team, but also for the operations folks, right? They've got to walk us around, they got to get us access and so on. So once we have the plan, then it's a matter of simplifying it and simplifying it, simplifying it again, such that we have something that can be executed very quickly with a minimum amount of risk to the operations environment, maximizing the visibility we get into where our risks are and delivering some value back to those operational folks. So high level for assessing OT, how do you do it, right? You plan and execute it as a project. You get buy-in from multiple levels, all the way down from the COO to the director level, to the manager level, to the guy I like to call the silverback gorilla, the guy who's been there forever, who's got a lot of pull and a lot of influence, even though he doesn't have a title, right? That type of individual who you also need to get on board and get assistance from, because he knows where all the skeletons are buried. So you got to have buy-in from multiple levels. You need to balance that effort with risk identification, as it is a massive amount of effort to look at all these environments, things that have been in place for 10, 20, 30 years, things that we do not have good documentation on. We need to do best effort and blend the controls assessment using a framework approach, such as what NIST provides us, with technical checks, such as using NIST's passive vulnerability scanner with config reviews by something like Digital Bond. So create that methodology, then simplify it again, get it as lean and clean, because our goal is to get in, to demonstrate success to the operations folks, to get a bellwether where we are today, to identify that we do need a cape, and to start the process, not to do something exhaustive or introduce any risk into the system. Once we got that done, it's all a matter of execution. So in conclusion, what we looked at today was, hey, look, there really are two layers of security, and IT is the area, it's the layer that we're most comfortable with. It's the area we've been focusing on for the longest. It's the area that we've been beefing up time and time again, because that's the area that criminals have been targeting. OT is largely untapped. It's an area where there's a lot of fog, a lot of mist. It is an area that thankfully criminals have not been going at significantly outside those highly publicized things such as the New York Dam and the Ukraine power supply or power station. But of course, it is an area that with targets of opportunity from everything from malware to ransomware to all these types of things are now discovering as these systems are online and the systems are rapidly aging. So what is the real threats landscape at this point in time? Primarily targets of opportunity, as well as being one step ahead should a determined attacker actually choose and decide to go after the operational technology that's protecting and sustaining organizations. How can we secure it from a compliance perspective? Well, most of us don't have compliance mandates about this, which is one of the reasons why it's kind of a foggy area, which is one of the reasons why it's kind of an uneven state. But we can tie it back to NIST, we can tie it back to important things like safety, especially for food and medical, and we can tie it back to important things like quality, especially in terms of manufacturing. So with that, we presented a way to unify those controls around a compliance framework and then do technical validation and testing. And along with the technical validation and testing, doing walkthroughs and documentation reviews to get some good insight as to what our operational technologies are. Once we have that insight, we can then look at ways to integrate operational technology within the IT security programs around risk and control frameworks so that we're reporting and tracking it consistently, doing these periodic assessments, expanding the scope and the technique as we get better and faster at it so that we can get better visibility into this foggy road and build up our roadmap. Also integrating these technologies, operational technologies, into a vulnerability management program. So oftentimes with these technologies, yes, they've been in the field for 10 years, yes, they were patched when they're deployed, but there's been 3, 4, or 5 different updates, which is again something we'd find from past vulnerability scan or documentation review, 3, 4, 5 updates that that could be applied, that could close vulnerabilities, that could close privilege escalation and now service weaknesses, et cetera, et cetera. Then finally, integrating the OT into our monitoring, incident response, and recovery plans. Do we know when someone's attacking it? Do we know when someone's going at it? Do we have insights into those things? And in terms of incident response, do we have a plan in place that should someone shut off a water valve or turn on a water valve over our data center or stop an elevator or disrupt in manufacturing, do we have a plan in place to recover that device, to re-image it if needed, reload it if needed, replace it if needed, God forbid, and get the organization back operational? Is the fundamental practices and programs of our IT security organization applying to these OTs? That's the next step, right? Once we lift the fog, we build the roadmap for bringing those technologies into the fold and starting to secure them. That's all I have today. Hey, I really appreciate everyone joining us today. I know a couple questions came in, so if you ask some questions, don't worry, we'll get to you. We're going to get back to you guys over email. To reach out to my strategy team, you can use the email address that's listed on screen. That's CBI Security Strategist at cbihome.com. So drop us a line. We're happy to talk to you in greater depth about operational technologies or any of the topics that we cover on these webinars. And really appreciate your time today, and we will see you at the next one. Thank you so much.